Hi, my name is M. Eifler. In this video, I'm going to introduce the concept of a social mixed reality developer platform and show two examples of how programming might work from within the creation environment. This is a tool not just for being together in a virtual space, but a way for designers, developers, and makers of all kinds to collaborate in world-building immersive software from within mixed reality. Most mixed reality development currently happens in Unity or Unreal, both of which were designed for the development of flat-screen video games. But the goal here is to build worlds and interfaces, program interactions and models, and work together, all from within mixed reality. Now, let's get back to those two examples I mentioned earlier. First, we'll see how a customer can add a custom tool to their workflow using deterministic programming, and then we'll see a method for introducing a behavior using AI. We'll start out in Maquette. I found this foggy little lighthouse island in the pre-made environments in Maquette. The environment itself is entirely static. So I want to introduce a new tool, the hand tool, to let me or the users using the software that I am creating within the developer platform interact with things in the world. I'll show two ways that the hand tool interacts with the world, but first let's just start with opening and closing a door. I'm going to give my user-generated hand tool 5 hotspots, one for each of the fingers. Now, using two simple coding blocks, one for a branching if statement and one for a then, I'm going to program a behavior into the door and the hand simultaneously using the hotspots. We'll see here I'm using the pink hotspot of the pointer finger and part of the door, this red flat circle for the door handle. Now, you'll notice that there is a bug in my code as I program it here for the first time. We can see that if the door is closed and the pink dot of the pointer finger touches the red circle of the door handle, then the door will open. But if the door is open and that same interaction occurs, the door stays open. I did later on fix this bug, but for now there's just a bug in our code. Now that our hand tool can operate the front door of the house, let's expand its functionality by having it operate the steering wheel in the car. First off, I made the car a little more usable by adding seats and a steering wheel, and now let's get to the programming part. I copied over my previous script, and we're going to edit it using the car object and the steering wheel object. You can see here that if the hand is touching the steering wheel, the car turns on. And if the car is on, we can see two outcomes. In this case here with the arrows, I'm assuming that the steering wheel is a gestural block. So if I hold the steering wheel with the hand tool and turn it to the left, I could save that turn as a gesture with this left turning arrow, and the same with the right turning arrow. So if the steering wheel is turned left, then the car is also turned left. Currently, my program doesn't have the car going forward at all. So if we turn the steering wheel, the car would just swivel on its axis. Now, you might have missed it there, but programming by gesturally turning the steering wheel would require another level of programming to introduce it into the system. So we're going to talk a bit about gestural programming using AI, but I'm going to switch over to another program called Anyland in order to show you that. This is Anyland. It's a world building tool mostly meant for people to build interactive worlds where they can add some programming elements and behaviors to the objects in that world. So here we're going to see how we might program not the turning of a steering wheel, but a wave. To save this gesture as a training example for our AI, we're going to wave at this little wave at me dot in order to give it a few examples. Once we have the sufficient number of examples recorded, we're going to go over to this other station where a GAN is going to try generating from our examples new examples of waves so that not only can it recognize a wave, but it can also generate a new one. Then we can use these red and green drumsticks to further educate the AI on its correct or incorrect assumptions. If I just don't like a certain kind of wave, I can label it red or green if I think that it would work in my program. To further understand what the AI is really seeing as a wave, we have this explainer station. It uses the skeletal model that is built in for all gesture detection. And in this case, when we wave at the detector, it says wave detected because the side-to-side motion of the wrist joint. It also states that this side-to-side motion is greater than any forward to back motion, a motion that we might consider shooing or batting instead of waving. This station is very similar to feature detection, in which a slider is connected to a certain feature set in the data, allowing the user to manipulate the slider to better understand what that feature is, and then human label the feature for better interpretability. This is just one example of how a social mixed reality developer platform could combine deterministic and AI programming, all from within mixed reality headsets, to give customers a rich, powerful, and immersive productivity tool. Thanks for watching.